graph representation ആണ് basically semantic network എന്ന് വെച്ചാൽ. അതാണ് അടുത്തത്. Okay. Then we are going to the semantic nets. Okay, semantic nets. So semantic nets also used for the knowledge representation. And what is semantic net? So the main idea behind the semantic net is that meaning of a concept comes from the ways in which connected to other concepts. So based on the semantic net is created. Okay. So this is the base idea behind the semantic net. Okay. The main idea behind the semantic net. The main idea behind semantic net is that the meaning of a concept, the meaning of a concept comes from the ways in which it is connected to other concepts. It is connected to other concepts. Based on this idea, the semantic net is introduced. So, what is semantic network? So, first we discussed the big idea. The concept is that is the meaning of a concept comes from the ways in which that concept is related to other content. Okay. Semantic network use that idea. Next. So what is semantic network means? In a semantic network, information is represented as a set of nodes. Okay. So basically it is a graph representation. In a semantic net, information is represented as a set of nodes. We know these nodes will be connected to other nodes. So the set of nodes connect each other by a set of labeled arc. Okay. Basically it is a graph representation. So there will be nodes and the nodes are connected to each other. So arc and arc are labeled. So what is in this case, what is node? Node represent the knowledge. Okay. Node represent the knowledge and nodes are connected each other. Okay, the nodes are connected each other. So basically node represent the knowledge or concept. Okay, and these are connected each other. This connection, so what connection means? The connection is a labeled connection or labeled arc that represent the relationship among the node. Represent the relationship among the node. So that is the okay. So there are nodes and labeled arcs. Okay. That is the basic concept. Okay. So basically I take this example. Okay. So this is a node and another node. So a mammal is a concept in the real world. Okay. Person is another concept in the real world. Okay. Then we will use a noun from person to mammal to represent the relationship between mammal and person. And this relationship is, we are using a is a relationship here. Okay, is a relationship. Okay, we are using a is a relationship. And similarly, this is a nose. This nose has part relationship is used with the person. Okay, person is a concept. Nose is another concept. How nose is related with the person? We are using a relation hath. Okay, has part. Has portion is used. So try to understand the concept. So similarly, you can note this. This is PV race. Okay, basically it is a person name. Okay, or a PV race. It's a team name. Okay, not a person. PV is a team. It's a team, and it is an how it is related to the person. It is an instance relation. Okay, it is an instance relation. So you can note is a has part instance. These are the three type of relations we are using in the semantic network. Okay, is a instance, has part. These are the three types of relations we are using in semantic network. So basically, we can first we can familiarize with the various relations. Okay, first we can familiarize with the various relations. Types of relation: is a relation, instance relation, and as part relation. Okay, so what is the use of a is a relation? What is the use of relation? So here in the semantic network, is a relation is used to represent the subclass concept. So in the semantic network, is a relation is used to represent the subclass, superclass relationship. Okay, you know, it's a mammal. Person is a subclass of mammal. Okay, to represent that, we are using is a. Okay, so for example, okay, you can understand clearly. So mammal, there are set of mammals. Mammal is a group of animal, group of different type of animal, and person is belongs to that class. So person is also a class. Okay, mammal is also a class. So the relationship between these classes is represented by using is a relation. Is a relation. Is a relation. Okay, try to understand the concept. That concept at first. Okay, what is the user relation? I will ask questions to someone. Anusri. Anusri, what is the use of an user relation? Relation in semantic network. What is the use of is a relation in semantic network? Okay, it is used to represent the subclass relationship. Okay, so and this concept mammal is a class, person is another class. Okay, so the relationship between is another is instance relation. Okay, an instance relation. So what is an instance relation? For example, PV race. Okay, okay, PV race is a particular person name. Okay, is a actually what is PV race? It is a person name. Okay, PV race is a person name. It is a particular instance of a person. Okay, for example, Anusri. Anusri is a particular instance of a uh, girl, girl class. Okay, so similarly, Fajr. Fajr is a particular instance of boys class. Okay, S8 boys class. So that type of n is represented using instance relation. Okay, so what is instance relation mean? Is used to show that the object concept is a particular instance of this class. Okay, so try to what is the concept of instance relation. Okay, so we discussed is a and instance relation. These are the types of relations we are commonly using. Okay, is and instance, and we can use other relation names also. For example, and depending on the problem, we can give different arc names. Example, PV race is a person name, and blue class of color. Then, or a uniform color, color. Then I can add an edge like this. Okay, it's a uniform color relationship with it. So here the uniform color. Okay, here the relation is uniform color, and PV is uniform color is blue. We can interpret like okay. Similarly, team is another relation. This belongs to which team? Bookline Dodgers. Okay, here they are using Bookline Dodgers, or this is a team name. Okay, this be team name. Hmm? You can use a cricket team name or etc. Okay, next book, Bookline Dodgers is a rugby team name in America. Rugby is the common, is the most popular game. Okay, in US. So and they are using rugby. Okay, rugby game. Okay, in India, cricket is the common name. So you can write your own example using cricket. Okay, for example, instead of PV Ray, you can use Virat Kohli. Okay, and here instead of the team name, you can use Indian cricket team. Then how it's related, its team. Okay, and the uniform color is, we know, men color in India is used. So in the real world, anything in the real can be represented using this type of semantic network. Anything, any concept in the real world. For example, Virat Kohli plays cricket for India. That concept in the real world can be represented using the semantic network. Okay. Similarly, anything in the real world can be representable using the semantic network, and that is in the form of a graph. Try to understand that concept. And here the bookline dodgers means, what is bookline dodger? What is actually the bookline dodger? Hello. 1 minute. Hello, Spinraj. Hello, Ashwati. Can you hear? Hello, Ashwati. Can you hear? Okay, okay, okay. Just to reply, I am just checking the connection. Okay, okay. So, in this example, I am coming to the point, and in this example, books is a team name. Okay, okay, team name, and PV is a particular person in that team. Okay, so and it's a particular person of the class person, so instance related, and person belongs to the mammal class person, not a single person, a lot of persons will be there. So person class is related to mammal class using is a relation, and we can attach different types of general relationship: uniform, color, team, has part also. We can consider as a general relation. Okay, for example, a person has nose. Okay, person means nose is a part of person. We can use has part relation. Okay, so this is semantic network concept. Okay, this is semantic network. As I told, you can represent most of the concept in the real world using semantic network. I'll try to show one example. For example, you can note this point. Okay, here three predicate expressions is given. Okay, here uh, three predicate calculus representation is given. That is, Marcus is a man. Marcus married to Madonna, and Madonna give a flower to Marcus. Basically, it is an English sentence, English story. Okay, so an English story, actually, it is a story. Okay, Marcus is a man. Marcus married Madonna, and Madonna gave flower to Marcus. Okay, we can represent this story or represent the sentence in the predicate calculus in this single sentence. Okay, but the same can be represented using what? Semantic net also. Okay, we can represent the same story using semantic net also. That is the application of using semantic network. Okay, so this is the corresponding semantic network. Okay, so this is the corresponding semantic network. We will study how to draw this type of semantic network. Okay, so this is the application. Okay, anything in real world can be expressed using semantic network. Okay. Now we are going back to the. You can notice also. This is a predicate. This you can to. For example, India won against Australia in the series by 3-1. That type of sentence can be expressed in the semantic network. That we will study later. We will discuss later. Now we are going back to the semantic network concept. So, okay. So basically, you understand what semantic network. Okay, now you have a clear idea about what is semantic network. Okay? What is the use of semantic network? Okay, so what is the use? To represent various types of concept or knowledge in the real world, semantic network can be efficiently used. Okay, that is the importance of semantic network. Okay, next, intersection search. So, what is intersection search means? The relationship among the objects in a semantic net can be found by the relationship among the objects. You can note this. Uh, Relationship among the objects in a semantic network can be found by pulling the activation out from each of the two nodes and seeing where the activation met. For example, there are two objects is there. I want to find the relationship between those objects. Then you can use intersection search. So the relationship among the objects can be found by using intersection search in semantic concept. So what is the use of intersection search? Okay. So what is the use of intersection search? Actually, Saurabh. Okay. 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 What is the use of intersection search? The relationship among the objects in a semantic net can be found by spreading the activation out from each of the two nodes and seeing where the activation met. This is the method of intersection search. Okay, the relationship among the objects can be found by using intersection search. The concept is simple. From the two nodes, we spread the activation and try to find out where it met. So let us come to an example. For example, suppose you can check this question. Okay, what is the relationship between Chicago and Bookland Dodgers? Okay, Bookland Dodgers. Okay, so uh, okay, what is the relationship between Chicago Cubs and Dodgers? So there are two objects. One is Chicago Cubs and another is Bookland Dodgers. So let us check what is the relation. So where is Bookland Dodgers? This is Bookland Dodgers node. Where is Chicago Cubs? Chicago Cubs is here. Okay. Now we want to find uh, the relationship between those two. How can it possible? We will activate. We will go in this way. We will activate in this way. It will go here to picture. You can note this. It is a very simple concept. We will go in this way. Okay. This will go in this way. This will go in this way. Okay. Then similarly from here we will go the activation in this way. It will meet at this point. Okay, it will meet at this. So this is, and the previous I told the rugby, not it is a base. Okay, it is actually baseball. Okay, uh, baseball is very popular in US countries, also in rugby, also in popular. Okay, anyway, baseball player. So we'll get an idea. This is the point they made. So we can say that they are both teams of baseball players. We will get it. This is the answer. They are both teams of baseball players. Baseball players in the teams are and then Chicago and the Bookland Dodgers. So this is the concept of intersection search. Sometimes in the exam they may ask intersection search. So just I covered that topic, and we don't want to bother too much about the intersection search. Okay. From the exam point of view, we don't want to bother too much. Just we want to represent or say what is intersection search. Okay. Okay. Now next we are going to discuss represent non-binary predicate. Okay. So uh, representing non-binary predicate. So what is binary predicate? What is binary predicate? What is a binary predicate? In the predicate, we discussed about the predicate representation. Okay, so usually it will take this form. Inside the bracket, we will place symbols. Okay, there is a predicate. Outside the symbol, there is a predicate, and inside there are symbols. If there are two symbols only inside this, then it is called a binary predicate. Okay, so it is easy to represent binary predicates using semantic network because there will be two. Okay, try to understand that concept. Suppose it is X and suppose it is Y. Suppose it is Y. Then we can represent it. We can easily create a semantic network. X is an object, Y is an object, the relation. Then what is the relation? P is the relation. Okay, P is the relation. Okay, we can represent in this way. But what's the problem here is there exists non-binary predicate. Non-binary predicate. What is a non-binary predicate? I hope you can get the idea. What is a non-binary predicate? It contains less than 2 or greater than 2 predicates. Okay. For example, this only one predicate is there. Okay. Only one predicate. Only one symbol in the predicate expression. So this is a non-binary predicate. Similarly, more than one symbols may come. Okay, more than one symbols may come for an X, Y, and Z. So this is a three variable predicate. How can represent a three variable predicate in semantic network? How can represent a single variable predicate in semantic network? How can represent four variable predicate in semantic network? That are the issues we need to consider now. Okay, so I'm just reading this expression. Semantic nets are natural way to represent relationship that would appear as instance of binary predicates. That is, semantic network naturally suitable for expressing binary predicate. As I told here, X and Y, I can represent X related to Y as P. But if there are more than one predicates, okay, I will give some examples of binary predicate. For example, person, mammal. The relation is a. PV is person, instance. Okay. PV is booklet dodges. Team. PV is blue. It is uniform color. Okay. That is equal to this. This is the corresponding network of that. Okay. You can note this is the semantic network and this is the corresponding predicate logic of that semantic network. So in that only all predicates are in binary form. Okay, so that is very easy to understand. Okay, but what is the problem is, but the knowledge expressed by predicates of other varieties. Okay, means what is meaning? Varieties means and other variety means number of variables actually. Number of variables in the predicate. Okay, that is the meaning of varieties. number of variables. Array T. The term means number of variables. Some other the program number of variables can can also be expressed in semantic network. Okay. So naturally, semantic network is suitable for binary predicate, but expressed by predicates of other array can also be a node. So what is meaning? It can also, but there are some other methods to handle that case, but that can also be expressed in semantic network. So that is also the advantage of semantic network. Okay. So non-binary predicates also can be expressed in semantic network. Okay. But we need to handle that case separately. Okay. For example, unary predicate case. First, we are taking the unary predicate case. So, how can handle the unary predicate case? For example, you can check man Marcus. This is a unary predicate. So, what I will do is that I will convert this predicate to a binary predicate. So, actually, how is done? We know Marcus is a particular of the man class. Okay, so Marcus man is a set of persons or man class. Marcus is a class. So Marcus is an instance. Okay, note that point. That is, Marcus is a particular instance of man class. Okay, so I will use instance relation. Then I will draw the corresponding semantic network. So how can I unary predicate? First, I will convert it into binary predicate and I will draw the corresponding semantic network. For example, Marcus, man, and this is instance relation. Okay, instance relation. This is instance relation. Instance relation is instance relation. Okay, this is the method. Okay, so that is a very simple case. Now we are going to more than two predicates case. Okay, please give attendance in the chat box. Okay. Please give it in the roll number wise order. Okay, Abhilash, from starting from Abhilash, please give the attendance. Okay. Hello, Dhanyaja miss.
Sir.
Miss Kanala. Okay, 1 minute. Okay, thank you.